Hi, I'm Ray-Ven, and me and my partner, Jailene, had put a review of a section of Chapter 14 for you guys. And basically, we broke it up into two questions. Our first question is, what are the major differences between inheriting a dominant trait and inheriting a recessive trait? So here we put together a chart, dominant on the left side and recessive on the right side. And our question is, how would it be affected? If it was to be affected in a dominant trait case, you would only need one allele to be affected. And for a recessive trait case, you would need two alleles to be affected. Which basically means for a dominant trait, only one parent has to be affected. And for a recessive trait, both parents have to be affected for you to be affected. Which leads us to our second part of the chart, offspring. In a dominant trait, you have a 50% chance of giving this disease off to your children. And in a recessive case, you only have a 25% chance of giving this disease off to your children. And this leads us off to our second part. What is the difference in phenotype between a heterozygote of a dominant trait versus a heterozygote in a recessive trait? And together we put a chart, dominant on the left side, recessive on the right side. And our two examples are Huntington's disease for a dominant trait and cystic fibrosis for a recessive trait. So in our dominant case, we're going to be using the letter H because it stands for Huntington. H. Our genotype for a heterozygote of a dominant trait, in this case of Huntington's, is capital H, lowercase h. And in this case, that means our phenotype will be affected. And for a recessive and cystic fibrosis, our genotype will be capital C, lowercase c. And this means that the person who has this disease will not be affected. But instead, there are a special thing called a carrier. And basically, a carrier is a person who has the allele or has the gene of that disease, but physically doesn't have that disease, but can give it to their offspring later on. Now here's an example of a Punnett square with Huntington's disease, with a genotype of capital H and little h, and a regular genotype of two little h's. So as you can see here, we're going to draw our Punnett square with our heterozygote parent that is affected and our normal parent. Now here you have a capital H and lowercase h, two lowercase h's, another capital H and lowercase h, and two lowercase h's. And in this case, this is where you get your 50% chance of your offspring being affected by Huntington's disease. And if we do the same thing for cystic fibrosis, on the other side here, where we have two carriers, capital C, lowercase c, and a capital C and lowercase c, we end up with two capital C's, a capital C and a lowercase c, a capital C and a lowercase c, and two lowercase c's. And this is where you get your 25% chance of having offspring with recessive trait disease, where both parents are carriers of this disease. And in Huntington's, only one parent has to have the disease. This is our section of Chapter 14. And after watching this video, I hope you have a better understanding. Thank you.